Okay, in this video, we're going to be looking at linear measure. And now in this video, we'll be talking about the English system, how to convert units of measure. Also, we'll talk about dimensional analysis or unit analysis. Then we'll talk about the metric system, distance properties, the distance around a plane figure, the circumference of a circle, and arc length. All right, we'll first talk about the English system of measurement. Now, the English system of measurement is usually going to be involving these units of measure: inches, feet, yard, foot, and mile. And their equivalents are this. If you have 1 yard, it's equal to 3 feet. And also 1 foot is equal to 12 inches. Now, in this case here, 1 yard can be also equivalent to 36 inches, simply because 1 foot is equal to 12 inches. So 3 times 12 inches will be 36 inches. So 36 inches is equivalent to 1 yard. And 1 mile can be equivalent to 1,760 yards or 5,280 feet. The reason being is because there are 3 feet in a yard and you have 1,760 yards. Multiply 1,760 by 3 to get 5,280 feet for 1 mile. An example of converting a unit of measure would be to convert 5.25 miles to yards. 5.25 miles, we want to convert that to yards. Well, we know that a mile is 5,280 feet. Well, if 3 feet make up a yard, then 1 foot is going to be 1/3 of a yard. So we can use those to convert from miles to yards. So here we take the 5.25, multiply that by 5,280 feet, because 5,280 feet is equal to 1 mile. Okay, now we'll have the answer in feet, but we want it in yards, so we have to take 1/3 of a yard. So 5.25 times 5,280 times 1/3 would give us 9,240 yards. Okay, now the quicker way of doing that would be take the fact that 1,760 yards is equal to a mile. So you'll take that 5.25 miles and multiply it by 1,760 yards. So 5.25 times 1,760 would be 9,240 yards. Okay, next is the dimensional analysis. This is a process to convert from one unit of measure to another. And this process does work with unit ratios. So if you were converting 5.25 miles to 1 yard, then you had the 5.25 miles. The fact is that a mile is 5,280 feet. So we'll convert from miles to feet. We're converting from miles, so the miles will be in the denominator, feet will be in the numerator. And their respective equivalencies will be in their proper place. The one would go with the miles, because 1 mile is 5,280 feet, so we put the 5,280 with the feet. That way these miles will divide out. But we want to convert it to yards, but we know 3 feet make up 1 yard. So we're converting from feet. Feet will be in your denominator and yards will be in the numerator. 1 will be on the top because 1 yard is equivalent to 3 feet. That's why the 3 feet is in the denominator. Divide out the feet and multiply 5.25 times 5,280 divide by 3, you'll get 9,240 yards. Again, the quick way is the fact that 1,760 yards is equal to a mile, so we use 1,760 over 1. Because we want to get rid of the miles and convert to yards. So 1,760 goes on top because 1,760 yards is equivalent to 1 mile. Multiply those two, you'll get 9,240 yards. All right, an example is if a cheetah is clocked at 60 miles per hour, what is its speed in feet per second? Okay, now in this case here, 60 miles over hours, 60 miles per hour. We want to convert that to feet per second. Let's convert that to feet first. Well, a mile is 5,280 feet, so we have this dimensional analysis here. 1 mile will be in the denominator, 5,280 feet will be in the numerator. Keep in mind, whatever you want to convert from will be in your denominator. Whatever you want to convert to will be in your numerator. So 5,280 feet will be on top, and the 1 mile will be in the denominator. That way these miles divide out. So it'll be in feet per hour. We need feet per second. So now we're going to use the fact that 1 hour is 60 minutes and 1 minute is 60 seconds. So we have these two analysis here. 1 hour is 60 minutes, so it would be 1 hour over 60 minutes because the hour is in the denominator. And minutes is in the denominator, so we have to write it like this: 1 minute on top and 60 seconds on the bottom. Okay, so here, cross that out for the minutes, cross this out for the hours. Now, we can cancel one of the 60, so we're left with 5,280 divided by 60, which will give you 88, and it will be in feet per second. So 60 miles per hour is equivalent to 88 feet per second. Next, we'll talk about the metric system, which is a fairly easy unit of measure to use, because in the metric system, this is equivalent to our base 10 system. Okay, so kilo, which is a prefix, lowercase k is the symbol. That factor for kilo is 1,000. So kilo represents 1,000 units. Hecto, which is lowercase h, is 100 units. Deca, abbreviated with DA as its symbol, is 10 units. Now deci, which is lowercase d, is 1/10 of a unit of measure. Centi, which is lowercase c, is 1/100th of a unit of measure. And milli, which is lowercase m, is 1/1000th of a unit of measure. So if we're dealing with the base unit of a meter, okay, each one of these have a relationship with meter. That's your base unit here. And this also works with liters and with grams. So the base unit could be one of these three things. It could be meters, it could be liters, or grams. So in this case, we're dealing with meters. In this case, since we're dealing with measurement, 1 kilometer is going to be 1,000 meters. 1 hectometer is 100 meters. A decameter is going to be 10 meters. 1 decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. And a millimeter is going to be 1/1000th of a meter. Okay? And those are the symbols for the metric units for meters. And here's some benchmarks for the metric units here. For 1 meter, if you extended your right arm, the distance from the left shoulder to the tip of your index finger, if you was to point out your index finger, that would represent 1 meter. And then if you have your hand extended out, this distance going across is 1 decimeter. And then if you look at your fingertip, the length going across of that fingertip is 1 centimeter. And for a paper clip, the distance on that this small part right here, for your paper clip right there, that small part represents 1 millimeter. Those are just a few benchmarks that you can use to consider the measurement for a metric unit. And this is a chart that we use to convert from one metric unit to another metric unit. Okay? Usually, it goes from kilo to milli, and the base is right here. The base could be either meters, liters, or grams. Okay? And in this case, we can use this to convert from one metric unit to another metric unit by either going to the left or to the right. And if we have to go to the left or to the right, then that means in the answer we have to move the decimal point either a certain number of places to the left or the certain number of places to the right. And we'll look at a few examples that are like this one right here. Let's say we want to convert 1.4 kilometers to meters. We got 1.4 kilometers. We want to convert that to meters. All right, now let's look at this chart. We're going from kilometers to meters. That's the base right here. Kilometers to meters, you have to go 1, 2, 3 places to the right. So that means in 1.4, we need to move this decimal point 1, 2, 3 places. And then we're going to have to add 2 zeros to do that. So we have to move the decimal point 3 places to the right in 1.4 to get 1,400 meters. So 1.4 kilometers is equivalent to 1,400 meters. Part B is 285 millimeters, and we want to convert that to meters. Let's go back to this chart here. We're going from millimeters up to meters. From millimeters to meters, we have to go 1, 2, 3 places to the left. We have to go to the left 3 places from millimeters to meters. That's 3 places to the left. So in 285, we got to move this decimal point, and then the whole number, the decimal point is always on the end, so we need to move this decimal point 1, 2, 3 places to the left. So in this case, the decimal point is in front of the 2. So 285 millimeters is equivalent to 0.285 meters, or 285 thousandths of a meter, if you want to pronounce that particular decimal appropriately or incorrectly. Part C, 0.03 kilometers is equal to how many centimeters? Okay, we're going from kilometers all the way to centimeters. So from kilometers to centimeters, we need to go 1, 2, 3, 4, 5 places to the right. So in 0.03, we need to move this decimal point 1, 2, 3, 4, 5 places and add 3 zeros behind the 3. So 0.03 kilometers would be equivalent to 3,000 centimeters. Okay. So this is how we convert metric units. All right, next we'll talk about the distance properties. Number 1, the distance between any 2 points A and B is greater than or equal to 0. And I got a couple of number lines that are drawn here. Let's look at this one right here. Point A has the value of 2. Point B has the value of 6. Okay, the distance between those two is always going to be a number bigger than or equal to 0. So if I do from 2 to 6, that distance is 4, not negative 4. It's always greater than or equal to 0. Distance is never negative. So the distance from A to B is 4. Number 2, the distance between any 2 points A and B is the same as the distance between B and A. So in other words, AB is equal to BA. So in this case here, the distance from A to B is 4. Also, the distance from B to A is 4. Number 3, for any 3 points A, B, and C, the distance between between A and B plus the distance between B and C is greater than or equal to the distance between A and C. So AB plus BC must be greater than or equal to AC. The distance from A to B here is 3. A is at 2, B is at 5. That distance is 3. And then B is 5 and C is at 8, so the distance from B to C is also 3. Add 3 and 3 is 6. And notice that the distance from A to C, 2 to 8 is 6. All right, next we'll talk about the triangle inequality theorem. Now, in the triangle inequality theorem, you must be given a triangle, and you must be given 3 sides with lengths for that triangle. The sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. In other words, side AB plus side BC must be greater than side AC. In other words, to put it into perspective, the sum of the first 2 sides must be greater than the third side. Also, the sum of the second and the third sides must be greater than the first. And also the first and the third sides added together must be greater than the second. So in this case, can a triangle be made with sides that are 15 centimeters, 18 centimeters, and 37 centimeters? Let's look at this. If I add the sum of the first 2 sides, 15 plus 18, that would give me 33. Unfortunately, 33 is not greater than 37. So I can say that the lengths of these 3 sides cannot form a triangle. Okay, the distance around a plane figure. We'll talk about perimeter. The perimeter is always the length of a simple closed curve, or the sum of the lengths of the sides of a polygon. In other words, the perimeter is always going to be the distance around the entire polygon. And in these examples here, we're going to find the perimeter of each of the shapes. So the one on the left, where you have a triangle, where each side has a length of 3 centimeters, we just simply take the sum of each of the individual sides together. So add 3 plus 3 plus 3, you're going to get 9. So the perimeter here, or the distance around this entire triangle, is 9 centimeters. And on this one, this is a rectangle here. We got a length and a width, a length and a width. We got 2 lengths here, so that's 2 times the length, or 2L. And then we got 2 widths here, 2 W's here, that's 2W plus W, which is 2W. So here, this perimeter is 2L plus 2W. And by the way, this is the formula for finding the perimeter of any rectangle. 2L, that's 2 times the length, plus 2W, 2 times the width. Here we have a couple of more figures here. The one on the left is a square because each side has the same length of S. There are 4 of them, so the perimeter there will be 4S. And the one on the right is a 5-sided figure. Now notice that these 3 units are different from these 2. So I converted these into millimeters. Now if you recall, from centimeters to millimeters, you have to go 1 place to the right. So I need to go 1 place to the right here with the decimal point. So 3 centimeters will be 30 millimeters. In this case, 1 centimeter will be 10 millimeters, and 3 centimeters again will be 30 millimeters. You want to make sure that all of your units are exactly the same before you go ahead and add the lengths of all those sides. So add 30 plus 10 plus 30, that's going to give you 70, plus 60 is 130, plus 40 is 170 millimeters. Okay, so the perimeter of this figure is 170 millimeters. And then next, what is the perimeter of the regular n-gon with side S? You have an n-gon, which is a polygon, n sides. Each side has a length of S, so that perimeter is just simply n times S. All right, next we'll look at the circumference of a circle. All right, first we need to define what a circle is. It is a set of all points in a plane that are the same distance from a given point. And that given point is called the center. So here's the circle right here. The point in the middle of that circle is always the center. And the distance from the center of the circle to a point on the circle, that's called the radius. So from the center to that point on the circle, that's the radius. And then you have a diameter. That's a diameter, that's a line segment that passes through the circle. Okay? Starts at starts from a point on the circle, goes through the center, and ends at another point on the circle. So here, that right there is your diameter. And of course, the circumference is always the perimeter of a circle. That's the distance around the entire circle. And also the Greek letter pi, spelled pi. That's the ratio between the circumference of the circle and the length of that diameter. And this is the Greek letter for pi. And it's equivalent to 22/7, or as a decimal, 3.14. So if we want to find the circumference of that circle, if the diameter is given, we use pi times the diameter. However, if the radius is given, we use 2 pi times the radius. And here the diameter is always twice the length of the radius. So that's why it's 2 pi times the radius. So either one of these can be used. If the diameter is given, you use pi times the diameter. Or if the radius is given, you use 2 pi times the radius. And then the arc length. Here we have a circle. Now, this part marked off in green, that's lowercase l. That represents the arc length. So, this cursive letter L is the arc length. And this formula is going to be pi times r, which is the radius, times theta, that's this angle measure here, and it's divided by 180. Okay, that's the formula for finding the arc length of any particular circle, because the arc length is nothing but a piece of this circle. And you have to know what the angle measure is, and you have to know what the radius is to use that particular formula. Here's some examples of just that. Let's say we want to find the circumference of a circle with a radius of 2 meters. Okay, so here, I'm labeling this as part A. We want to find the circumference. We know what the radius is, so we need to use this formula. C is equal to 2 pi times r. C is equal to 2 pi times r because the radius is given. And in this case here, the radius is 2 meters, so we'll do 2 pi, replace the r with 2, so we got 2 pi times 2, and then multiply 2 times 2, you'll get 4 pi, and that's 4 pi meters, not centimeters. So this is 4 pi meters, which is what they have here. Okay, part B is finding the radius of the circle with a circumference of 15 pi meters. So here the circumference is already given. You want to know what the radius is. We have to use this formula, C is equal to 2 pi r. Now, the circumference is 15 pi. So we replace this the C which is our circumference with 15 pi. That's equal to 2 pi times r. Now to find out what r is being multiplied by 2 pi, so we need to divide both sides of this equation by 2 pi. Which means that r is equal to, now notice the 2 pi's are gone, I'm left with r. On the left side, these pi's cancel, divide 15 by 2, you're going to get 7.5. So the radius of that circle is 7.5 meters. Okay, part C. The length of a 25-degree arc of a circle with a diameter of 10 centimeters. So in this case here, I'm going to do this on another sheet. And this is part C. We have to use this formula. L is equal to pi times r times theta over 180 degrees. Theta is the angle measure, and pi, and then you got r is the radius. L is the arc length. In this case here, bring over the pi. R, now, notice the diameter is 10 centimeters. You need to know what r is. So if the diameter is 10 centimeters, the radius is 1/2 the diameter. So 1/2 of 10 is 5. Okay, so if you're given a diameter and you're trying to find the arc length, you need to find out what that radius is by taking half the diameter before you can use this formula. So in this case here, the r this time is 5, so we have pi times 5 times, we have a 25-degree arc, so that's your angle measure, theta, 25, all that's over 180. Now if we simplify this, if I divide 5 into 180, that's going to go 36 times. And then pi times 25 will be 25 pi divided by 36. And in this case here, I'm going to let pi be 3.14. So I got 25 times 3.14 divided by 36. To 2 decimal places, this will be 2.18 centimeters. Okay, so here, this is 25 pi over 36 centimeters, or we can say 2.18 centimeters if we were to convert that to a decimal. Okay. And part D is the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. So in this case here, we're trying to find the radius of the arc using this formula. We have a central angle of 87 degrees, that's theta. The arc length is 154 centimeters, that's your L. So here, we got 154 is equal to pi, I'm going to let that be 3.14 times r times theta, which is 87 degrees. That's your angle measure, or the central angle measure. That's divided by 180. Now I'm going to simplify this. This will be 154. That's equal to 3.14 times 87. That's going to be 273.18. So I'm going to have 273.18 over 180 times r. Now to find out what r is, I'm going to take that 154, and I'm going to multiply that by the reciprocal of 273.18 over 180. And that's going to be 180 over 273.18. So 154 times 180 divided by 273.18. That's going to be approximately 101.4 centimeters. So in this case here, the radius of that arc whose central angle is 87 would be 101.4 centimeters. Okay, so that's how you would do those particular problems that deal with the circumference of a circle and the arc length of any particular circle. And that will conclude this particular video on linear measure.